Okay, in this question, they're actually telling us that these two figures are similar. What we have to do is we have to work out what the ratio of their sides are and then determine what the scale factor is. First question, first part. With these ones, we have to work out what the ratio of the sides is. How many of the sides do we have to use? Like how many of them do we have to check to get the ratio?
We have to check 3.
3?
2. Oh, no, 2.
2?
Yeah, 2, yeah.
Because it has a little symbol so they're all
No.
the same.
Yeah, 2. Just 2.
I want you to read the question. Aiden, I want you to read the question. Just in your head, the first line. Not the A or the B, the first line.
2. No.
Oh,
4. 2 figures
4.
are similar.
4 sides.
Are we proving that they're similar?
No.
They are similar.
They are similar. The question tells us.
We are supporting.
How many do we have to use to find out the ratio?
2. Because, actually no.
Are you saying 2 or 1 on each? Wait, are you saying 2 sides on each?
Yeah.
1 of each, yeah.
No, but
so
you'd need
4.
more than that.
Jake, why 1 on each?
You'd need 3.
Their sides. I get it.
Oh, because this is what it
You only need to do 1 on each.
What?
Because it says
Why?
2 figures. They are the same.
They've already told you that they're similar. What does similarity mean? It means all corresponding sides are in the same ratio. Does that make sense? Which means we only need to use 1 set of corresponding sides because they've already told us they're similar. We don't have to prove that. Does that make sense? Okay, so all we'll do is pick 1 pair of corresponding sides. Okay, pick a pair. Levi, pick a pair of corresponding sides. Which ones?
6 and 15. Yeah. No, is there a 6 and then
Thank you, Levi.
Oh, is there a 9? No.
Nice try.
And then a 9. And then we made 6 and
No, wouldn't have been, it was 6, 2, 9. And that would have been
6 minutes to
2
9.
thirds.
That would have been what?
2 to 3.
That would have been what?
Okay, so the ratio of their sides.
There's 2 people in that one.
There we go. That's the ratio of their sides, 6 to 15. Can it be simplified?
Yeah. I reckon it can.
Can it be simplified?
No.
It obviously can be if we say no, then you don't say nothing.
No.
Kirby, can that be simplified?
No.
Is anyone going to do what I told them to do if they're not sure if they can simplify a fraction? 2 to what? Beat them, Levi, beat them.
2 and 5. 2 to 5.
It's alright, at least you got that there was a 2 there.
Yeah,
Couldn't it be something else too?
Well, it could be. What else do you want it to be? 4 to 10?
Well, it could be.
Wait, I don't get it to
It could be 60 to 150.
You can't get too
be-
low though. 3.
3 to 7.5.
That's not.
Don't like using
Oh, you
decimals in
can't
there.
use the same one. But
I don't-
like, I mean, like, it's
It is 3 to 7.5 as well.
5 is no, but I mean, like, couldn't it be
3 times.
3, 6,
Oh, my head
It should be what, sorry?
2 to 3?
No, it couldn't be 2 to 3.
What?
How could it be 2 to 3?
3. 3 to 15.
But 3 is not the corresponding side.
Tim is making me pay 3.
They lost more.
You've got to use the corresponding sides. The corresponding side for 3 is the 7.5. So you'd have to do 3 to 7.5.
1 minute.
Does that make sense?
1 minute.
When we did these ones, we had to find the corresponding sides, correct?
Yeah,
Okay, well, in this shape, we've still got to use the corresponding sides. So which side corresponds to that one? The 15. So that's why we could only use the 6 and the 15 together.
yeah, I know, but you know how it's symbolized 2 triggers?
Yep.
Couldn't
No, because that fraction wouldn't simplify to 2 to 3. Because if you go how many 2's go into that, 3, you'd have to go how many 2's go into that.
Oh, yeah.
And you'd get 7.5. Cool? But that also goes to prove that they are in proportion as well. So, alright, so now we have that. Levo, what do we do next?
Well, I suggest that you just put it in its position.
You got absolutely no idea, have you?
No, sorry.
We read me.
Okay. Sorry?
We read me.
No, first we've got to finish this one. What have we had to do every time we've done one of these questions? We don't end on numbers. Thank you. We write a conclusion.
Yeah, that's what it's called. When you work.
Curly, what's the conclusion we're going to write?
That there are
Yeah, absolutely no idea either, have you?
All corresponding.
You're answering question A. The ratio of their sides is...
Okay, can
What?
I just ask one question because I wasn't listening?
No, then.
Oh, actually, I got it. I already...
What's the ratio of their sides?
Because you had too much sleep.
2 to 5.
That's it. Too much sleep.
Okay, that's question A done.
Thank you.
Now we're about to answer question B.
Should be the ratio of their sides are, not the ratio of their sides is.
Oh, that's an interesting question. What do you reckon it should be?
It should be R.
It is
Why?
2 centimetres equals 4
Because
centimetres.
nobody says the ratio of their sides is 2 to 5. They just did.
That's what it does say.
That should be they
The
are.
ratio of
Why?
the side, I think it is.
Because they are.
Can you
There's
just...
only one.
Is.
As a scale factor, 1 centimetre.
How many ratios are there?
1.
The ratio is 2 to 5. Not the ratio R.
Of their sides.
One, yeah.
are 2 to 5. I just wrote R.
The ratio of the sides in that shape is...
R. I'll say R.
It's only one ratio. There is only one ratio.
Okay, it just sounds wrong.
I know, because you're reading the plural of sides
Yeah.
and thinking that's the subject, but the subject in it is ratio. The ratio is 2 to 5. Okay? The ratio of the triangles is 2 to 5. The ratio of the quadrilaterals is 2 to 5. It's not R. It's always is and are always based on the subject of the sentence. Go.
Why did you put A above that?
Because that's all question A.
There's 2 questions. Why 3? To 7.
Because that's those two.
3, but then we didn't simplify. With the ratio of 7.
No, but if you were listening, you would have heard that there's a few questions about it, so we answered those. Yeah, this is why we listen in these. And it'll be interesting because you'll go back and you'll listen to this recording and you'll go, oh, I'm such a wally. I sort of listened rather than talking about smoke names.
Boyfriend.
You go,
Why
go.
is this recording?
Now, question B. It says, what's the scale factor? How do we work out the scale factor? What does that mean? Yes, it is lucky you're listening now. The ratio is 2 to 5. What do you reckon the scale factor is, Jacob? How do we work it out? What do you mean by scale factor? I'll give you a hint. In the first question, you've got it right.
5 centimetres or 1 centimetre equals 2.5 centimetres.
Thank you.
That was interesting.
What's he done? I know he's halved it, but what has he done?
Converted to units.
Yes, you've given me a unitary.
Oh, do you
Okay.
remember these unit things?
What you've done,
Yeah. I love them.
what you have done is you have taken it and made the first one to be a 1. Does that make sense? In the other ones we found it was 1 to 3.
So you just halved it.
He halved it, but if that was a 3, what would you do?
You would halve
If it was 3 to 5, what would you do?
Still,
You wouldn't halve it.
no, you go to 1.
Yeah, divided by 3.
What would you
If that was a 20, what would you do?
You go to 1.
Divided by 20.
Would you?
If that was a 12, what
See,
would
on
you
the
do?
scales, it's like 1 to...
The scale factor. Like you can have a ratio that looks like 2 to 5 because we don't like having fractions or decimals. But when we're talking about the scale factor, how much did you blow it up by? How much did you enlarge it by? You don't say, I enlarged it by 2 to 5. You say, I enlarged it 2.5 times. Does that make sense?
Like a map there, like 1
So then if that was 20 and that was 50, you'd have to divide it by 20 to the 50.
You divide it by 20, and in fact 20 to 50 give you exactly the same answer because you could have simplified that. But if you had 20 to 30, 20 to 32, something like that, or 20 to 33 is a better one, then you would divide it by 20 and you'd get a fraction or a decimal. Okay? What you want is to get that one to 1. Cool? Get the smaller one to 1.
Okay.
Okay? And now what we know, now how do you know if it's enlarged or reduced? How can you tell if it's enlarged or reduced?
They got it like
Enlarged is one and reduced would be the other.
Yes. If this one's the smaller one, you've gone from 1 to 2.5. That's what it was. It was 2 centimetres. It's now 5 centimetres. You've enlarged. Okay?
Okay.
You've gone from 2 to 5. Every 2 centimetre thing is now 5 centimetres. So you've enlarged it 2.5 times. If it was the other way around, if it was 5 to 2, everything that was 5 centimetres is now 2 centimetres. So you've reduced it 2.5 times. Make sense? So your conclusion is the scale factor. What do they want me to say? Okay. All we're going to say in this one is the scale factor is 2.5. Everyone happy with that? Is there happiness in the group?
There is.
I love happiness.